Hey guys, today we're going to answer the question, what is factoring? Now to do that, I want to use an analogy that just uses some whole numbers and processes that we're all familiar with. Let's imagine you have the number 35. Now, 35 is a good number, but what if we wanted to find an equivalent way to write this? How might you do that? Well, you could say, 30 plus 5. Or you could say 34 plus 1. Or 19 plus 16. Those are all equivalent ways to write 35 through addition. You could come up with a million ways to write it through subtraction. You could even come up with some division. But the idea of factoring wants us to rewrite something through multiplication. So let's think about how we could rewrite the number 35 through multiplication. I would write it as 5 times 7. I mean, technically there's 35 times 1, but that's kind of cheating, right? So 5 times 7. Those are two factors of 35. This is an equivalent expression to 35, and therefore it is a factored version of 35. Factoring really wants this idea of rewriting something as multiplication that is equivalent to it. Now, this is a really simple version, just using a whole number. Factoring really isn't just going to be whole numbers. It's going to be polynomials. 99% of the time, we're going to be working with polynomials when factoring. We're going to be taking something like this, x squared plus 10x plus 21, and we want to rewrite it as two somethings that multiply to become this. Now, do you think that's going to be so simple as just two numbers like this, like 8 times 4? No. It's going to be a little more complex. Factoring polynomials will always lead to binomial factors. Typically lead to binomial factors. There's always those corner cases in math where things are a little different or weird. But traditionally, and I do want to mention traditionally, there are some other cases, but traditionally, factoring will take polynomials and turn them into binomial factors. Now, we know what a polynomial looks like because I wrote one right here. 3 or more parts. Binomial factors are 2 terms, right? Hence the prefix bi, 2 terms. So therefore, what would actually end up happening to this polynomial is we would turn it into x plus 7, x plus 3. Now you may be thinking, how the heck do you do that? Where did you get those binomials from? Did you just make up those numbers out of thin air? No, I didn't. I had this pre-prepared and I already knew what its factored version was. This is something that we're going to have an entire video talking about how to do that. But I want this video to be focused on conceptually, what is it and what does it look like to be factored. Now, while we may not know how to factor right now, what we have talked about is foiling and using the distributive property among 2 binomials to create a polynomial. Hopefully you're pretty familiar with foiling right now. And if you need a refresher, there's another video and I'd highly recommend checking that out. But let's take a look at these 2 binomials. These are multiplying, right? That's what factoring is all about, is making those 2 multiplying factors. What would happen if we foiled these? X plus 7 and x plus 3, what would happen if we foiled those? Go ahead and pause the video, foil those if you want. See what you get. you should get x squared plus 10x plus 21 because they are equivalent. They're the same thing. Writing it like this or like this means the same thing. The only difference is that depending on what kind of mathematical operations we're doing, sometimes we want to see it written like this, but other times we need to see it written as its binomial factors. So the important thing is knowing that these two versions of writing the same thing are equivalent, and then eventually, very soon, the videos are going to be uploaded literally within the day, how to turn this into this. So that's the idea of factoring. That's the concept. If you have any questions about that idea, drop them below. I'll be more than happy to answer them as soon as I can. Otherwise, thanks for watching, guys, and I'll see you next time.